Hello, welcome to a new video of the series Discover SAP EWM MFS, where we look at all kinds of features, functionalities, backgrounds, components, whatever, in and around SAP EWM MFS. My name is Hendrik. I'm happy to have you here again, and I'm also happy to work together with Swisslog for this video series. We benefit a lot here of the Swisslog knowledge in and around SAP EWM integration with automation hardware. So thanks a lot. And as I mentioned already during the other videos, the Swisslog team is happy to support you with your automation projects. So if you're interested to work together with Swisslog, just look at their website. I put the link in the video description. Contact them, get in touch with them via LinkedIn, via social media, or directly via the contacts given on the website. Having said that, today is going to be a rather technical video. It's probably one of the most complex ones so far on this channel in this video series, as today we will be talking about the communication between EWM and the PLC. Now, this will be really a step-by-step lesson. We will look at the technical details, and we, as usual, we will look at one practical example so that you have a little bit easier entry into these rather theoretical stuff. We will grab a practical example, which is the removal of a HU from a high bay. So if you look at the picture here on the top of the slide, what this will all be about is a task which is created to remove HU from a rack. So physically from a ASRS, like a high bay storage, which is operated by a crane. You see it here. And we will send a task from EWM to the subsystem to remove one HU from the rack and drop it on a conveyor and move it somewhere else. And in this context, we will at first look at the induction of the communication. So when does it actually happen and why? We will look at the protocol which is used. So what are the rules for communication between EWM and the subsystem? We will look at how EWM prepares the creation of the telegram, and finally we will look at the actual creation and the transmission. So as with the other videos from this series, at least the last 2 or 3, I guess we looked at the layer model from the VDI right at the beginning, so I won't go into detail here describing the whole model again, so you can look at the other videos or at the other blog posts. I will link them down here where I described this already. But what we will do here is to look at the interface which is in scope of this video. And as before, we concentrate on these 3 layers here. So EWM basically being the warehouse management plus the MFS, and the PLC as a second player in this video. And what we have in scope today is actually here communication from this part here, so EWM as a source and the PLC as a destination. So quick recap. If you want to get details, then look at the video about the EWM PLC integration. That's also part of the series. Just a quick recap about the induction of the MFS relevance. So we talked about these components that are used to link EWM with a PLC, and we also talked about the induction which happens based on the queue. So the queue determination in EWM induces the MFS relevance. So if a queue is relevant for MFS, is customized to be relevant for MFS, then the tasks which are assigned to this queue will be flagged as being relevant to be passed to the subsystem. And we have a field here in the warehouse task table, which is KZ sub. And here you see in function module q.prep, determination of the relevance for the task. That should be it. As a recap, as I said, there are some details in the other video, but based on this, we know whether a given task is actually relevant to be communicated as a telegram at all or not. And in our example where we remove a HU from an ASRS, we know for sure this should be relevant, so we customize the queue in a way that it's MFS relevant and assign it to the resource. Let's look at the next important topic in this context. It's a communication protocol. You know, whenever machines communicate with each other, there need to be some kind of rule set. And this rule set is called protocol in this context. And this is not only true when machines are communicating, but also in our real life. So in order to explain this handshake mechanism, which is used here to ensure a reliable communication between EWM and the PLC as the two parties, I would like to take a real world example, and everybody who has kids will probably easily understand this, that it happens that you want to communicate with your kid, you want to tell something, you want to tell him or her what he has to do, or just inform him or her about something, and they just don't react. Yeah, so you're just talking against the wall, and you might have noticed that you repeat stuff over and over again. So that's like a normal behavior, that you want to get some kind of feedback from the person you're talking to in order to be sure that he got your point. And that's actually the handshake mechanism here. So assume you tell your kids what to do, and before they don't respond, yeah, daddy, I got your point, I got it, or just knock their head, before you don't get this kind of feedback, you will just repeat what you said over and over again. And only once you got the feedback, once you got the confirmation that what you said actually was heard, only then you start telling something else and some additional information. Yeah, and that's also what we have on a technical basis with EWM and the PLC. So we have a telegram which is being sent from EWM to the PLC, and then we got an acknowledgement telegram from the PLC to EWM. Now that's actually true also the other way around if PLC starts a communication. But for every telegram that we send, we expect an acknowledgement to be received. So, hey PLC, this is the information, please confirm that you got it. And then the PLC says, yeah, I got the information, you can send me additional information. And only if this acknowledgement is sent from the receiving party, only then the sending party is allowed to send the next information. If this acknowledgement is not being sent from the receiving party, then the sending party will just repeat. So tell your kids, tidy up your room. Nothing happens, nobody says anything. And then he said again, please tidy up your room. Please tidy up your room. And then they say, okay, we will do it. And then you start with something else, yeah? So as long as you don't know that the receiving party heard what you said, you will just repeat it. And in technical terms, this happens a specific number of times. And if no response received after X number of times, we just close and reopen the connection. And we come back to this later. I just want you to understand this right up front. And at the stages, we go into detail again here. Having said that, this is true on level of the communication channel. We also talk about this later again. We talked about the communication channel also in the basis videos, but it might be the case that there are multiple communication channels in order to communicate with the other party. So going back to real world example, if you talk to your kid, you might want to try to write a WhatsApp message in parallel. So you have one communication channel with your mouse and another communication channel. So if you send your kids a WhatsApp message, it might even work, although the other channel is not working anymore. Yeah. So this is just as a preparation. Thanks actually SAP and Jörg and Tobias. I took this from your blog post. So this picture here is SAP copyright. So Just don't want to get into trouble here. Good. So let's start with the example. We know what we want to do, remove a HU from the rack. We know roughly how the communication protocol works. And now we have the initial situation that we have a queue which is relevant for MFS. In this queue, there are multiple tasks. So, for example, for this ASRS, multiple HUs have to be removed from stock. So all those tasks are carrying the status Y in KZ subfield that I showed you before. And status Y means they are relevant to be communicated via a telegram, but the telegram has not been sent yet. That's the initial situation. And subsequently, the first step is the determination of the next warehouse task to be processed. So out of our pool of tasks, we need to decide now which one is the first one to get a telegram and to be communicated to the subsystem. And this happens via function module SAP EWM MFS WT-DET. And this function module is always called in the context of, for example, in the context of posting the creation of a task and the confirmation of a task to the database. There are some other spots, for example, this background report for MFS, which is running as soon as you start a channel. We come back to this later. But those two spots are very important, and you see there is some kind of loop implemented here. So whenever I create a task, I call the function module in order to check what is the next task to be sent to the subsystem. And it might be that we decide, okay, the task that I have just created can be sent, but it might also be that another task has to be sent. And the task which is just being created has to wait. When the other task is then being confirmed, this is the other spot, then again we check. Because it might be that the previous one was the last one to be created today. So there needs to be some kind of logic which still checks whether this one can be sent now. So whenever a task is confirmed, here you see the stack here, we also check whether there are other tasks left which need to be sent. So here, task is posted, and we call the subroutine here, which calls this MFS WT-DET update function module, and the same thing with the confirmation. And this update function module here, that actually calls then SAP EWM MFS WT-DET. What happens within WT-DET FM? We have a subroutine again here, and we check some stuff like the status of the PLC and the resources and the channel, whether all of these components are actually available. Is it possible to send something to our crane for ALX and Y? Is our communication channel available and all this stuff? So based on this, some of the tasks might already be sorted out, as we cannot send them anyway. And then we are doing things like checking the relevance of interleaving. So interleaving, where you first do a put away, and then the next task has to be a removal, and the next task again has to be a put away, just to save some travel time. And if this is active, of course, then when I just did a put away, the next task, even though it might have the highest priority, cannot be again a put away task. So it has an influence on the sorting in the queue. And then at the end we have multiple tasks which could be processed, and those tasks are then sorted via standard here based on, you know that also from manual environments, the latest start date, the priority of the task, and the warehouse order number ascending here. And then last but not least, there's some additional checks in case the HU that the task that we selected or the HU that we selected is sitting on a communication point, to ensure that for given communication points, we always ensure that HUs are processed in a FIFO sequence. Good, that's happening here in MFS WT-det. And then the most important step actually in this function module is the call of our most valuable player in this video, which is the function module SAP EWM MFS send, which is then handling the selected task. So this is being called in order to trigger the preparation and the creation of the telegram. So we covered the first step, the selection of the next task to be processed, and handed this or multiple tasks handed over to the send function module. So in our context, we handed over in the ODMO structure table, and we did not create a telegram yet. We just decided to communicate one or multiple tasks to the subsystem. In other scenarios, in a different context, it might be the case that this function module is already importing a telegram. This is not in scope of this video. This is a scenario where, for instance, telegram, which is buffered in the MFS delay table, we come to this later, is just read from the table and imported into this function module and just sent. This is not the case in our scenario. In our scenario, we just created the task and we assume there's just directly in the context of telegram creation, we call the telegram transmission. So we need to build the telegram at first. It does not exist yet. But just that you understand, we might also call this function module in a context where the telegram already exists and it's just being sent then via this module. So what do we do here? As with the other function modules or objects that I mentioned, I don't want to go into every single detail now, but I would like to explain some important steps so that you get a good understanding about what's happening. And as usual, you have some technical details here on the slides as well as in the blog. So we do one check at the very beginning. This is true for our example because we are using a resource to move a HU out of an MFS relevant storage type. We need to look at the resource and we need to figure out whether we need to create additional tasks. It might be the case that the resource type is set up in a way that it just takes the HU from the source, confirms it to the destination, and from EWM perspective, this is one task. You can set up EWM in a way, as you might know it from RF processing with resources, that we create two tasks. So one task from the source to the resource and an additional task from the resource to the destination. So we read the resource type, and as you can see here, take the way of confirmation from customizing. And based on this, we start filling fields in the telegram structure. And this is relevant, for instance, for the initial destination. So is the destination the resource, or is it the deposit of the crane ale here in this context? The next step, we proceed filling the structure which holds the telegram data. And for this purpose, we also need to make sure that we communicate objects to the PLC in a way that the PLC understands. And on the level of the PLC, a given object might not have the same convention or name like in EWM. And so you might have a specific bin number or conveyor segment number convention on EWM side, which is different from the one that your PLC vendor is using. And for this purpose, in standard, you have this object map table. You see a screenshot here from the application data, where you can maintain a manual mapping, but you can also call this body EWM to PLC object here, where you can just write some logic which covers the mapping for you. So if you have a specific pattern that is always true, so you have some, let's say, some dividing characters in EWM, and in PLC it's simply a string. Then you can make use of the body instead of filling every single mapping and for every single object manually here via the application data. So once this is done, we start locking the channel. Just one technical step, but I didn't want to skip that one because it's very important. And we lock the channel, so we just make sure here our process right now is using this communication channel to communicate with the PLC. Nobody else is allowed to use it now. If this fails, of course, we just return here and do not proceed. And finally, we read some technical details. First of all, about the telegram type, but also about the communication channel and its parameters, which is important also for the content of the telegram, like some filling characters or the handshake mode, which is used later. And last but not least, we have one body x MFS TLS send, which basically gives us the option to change everything. So we are giving the telegram structure, the internal structure with all the fields that we filled so far, we're giving it to the body, and you have the option to do whatever you want with it. And you can even change the telegram type. Okay, so at this point, we are actually ready to send. And so we collected all the information that we need to fill telegram structure. We checked the communication channel is ready. We got the body to do whatever you want with the content. Now we are ready to send. As I mentioned before, the protocol tells us we are only allowed to send something if what we sent previously has already been confirmed. And EWM uses the table SAP EWM MFS delay to store telegram data which has not been confirmed yet. So whenever we have a record here for the communication channel that we want to use, we have sent something, but it has not been confirmed yet. And that also means we are not allowed to send something else. So at this point here, we are actually ready to send. But if there are any waiting or unconfirmed telegrams, then our new telegram can also not be sent yet. And we need to wait. So that means if there is something in this table, and the check is happening here, we read whatever is in the table, and if there are telegrams in this table, so in this outgoing buffer, we do not send the current one. Instead, we add it to the table. This happens here with subroutine MFS delay add. And here at the end of the subroutine, you see we update the table. So telegram is actually kind of ready. We are not there at the point where we can send it. So if the table is empty, then we are allowed to send it. So option 1, store it in the table. I do not send it yet. And later another process will grab it and process it. For example, when we receive the acknowledgement from the previous telegram, from the one which is sitting there already, and we receive the acknowledgement, then right in the context of processing the acknowledgement, we will grab the record from this table that we just created for the new telegram. In our example, we assume the table is empty, so we can send the telegram. And so that's the next step, the actual, let's say, physical creation of the telegram. So we know we are allowed to send, and that means the next step is to pull a sequence number. And this is happening via function module MFS send sequence number get. This function module takes the sequence number from table SAP EWM MFS CCH. I put a screenshot here. In this table, a sequence number for every channel is being stored. You can also see the current state of sequence numbers from the warehouse monitor, from the MFS node, where you find a node for the communication channel. And this is always keeping track of the current sequence number. And the sequence number, again, is important for our communication protocol. Every telegram has a sequence number which is unique for a given time frame for the given channel. As long as the telegram with the previous sequence number has not been processed and acknowledged, then the one for the next sequence number cannot be processed. And here you see the sequence number is at first read from the table that I just showed you, then it's increased, and later the table is being updated with a new sequence number. And if you want to include your own logic here, there's also a body. Up to now, we filled our internal structure for the telegram, but we did not fill a telegram type specific structure, which might be different. So based on the telegram type, different fields might be filled with different information. That's happening in the next step, right after we pull the sequence number. And that's happening based on these two function modules here, whereas the latter is basically responsible to add filler characters. Even though I told you we figured out the MFS delay, this telegram buffer table is empty, even though we sent the telegram now, we will still fill it in this table. And again, we come back to the communication protocol that I explained before. We send the telegram in parallel, fill it into the table, because we want to be able to repeat sending the telegram in case we did not receive an acknowledgement. So basically, you remember what you said, because if the receiving party did not show you that it received it, you want to be able to say it again. Ahead of having dinner, you tell your kids to wash your hands. And then you just remember, okay, I told them to wash their hands. And as long as they don't get back to you and told you, okay, I will go and wash my hand, you will just repeat it. As long as they don't confirm that you got it, you will just say, okay, wash your hands. And a couple of seconds later, you say, okay, wash your hands, please. And in the communication channel in EWM, you define how many times you try sending the information and how much time should pass between repeating the information. But this is just to understand the communication protocol. In our example here, we are at a step where we want to send the telegram, and in parallel we want to store it in the delay table, and it will stay there up until the point in time where the receiving party, so in our example the PLC, sent an acknowledgement telegram telling us that the one that we sent has been received. Remember our protocol. Last step. Finally we are there, finally we can send the telegram. So it is stored in the buffer table, and now we want to trigger the communication so that actually data flows via our network between the application server of EWM and the server where the subsystem is actually running its logic. This is happening in function module MFS CL call, which is called from MFS send. We are still here in our MVP. And this function module is at first reading the communication details from the PLC and the communication channel. Our queue, our task is assigned to a queue, and the queue is assigned to the PLC. And the PLC has a communication channel, which is either a one-to-one relationship, or PLC can have multiple communication channels, and the channel is being determined based on multiple different criteria. For now, we just assume you only have one channel. Don't want to go into detail here. Let's just assume it's one channel, and the channel has a host address, so IP of the server where the PLC logic is sitting, and the port, which is used to address the application on the server. And on the other end, we have the PLC, which is carrying information about the way of communicating. You see the different options here, and you see how this case statement here in this function module, which is exploring or deciding which way to go. And so we have a SAP communication layer, which might be, which is just an RFC converter, like plant connectivity. Back in the days when APC, our push channel, was not possible, this was a common setup. So an RFC call and then a converter which induces the TCP/IP based communication. It might also be a proprietary communication layer which is used, for example, if you're working with a simulation in SAP. So instead of calling some external system, you just call some logic which is sitting in the same system. Or, and this is in scope, this video is a direct communication with the subsystem via our push channel based on TCP/IP. So this is the most common setup these days, and it's also in scope of this video. And this TCP/IP based communication is executed by class CLAPC X MFS TCP PLC. Here's the most important method, TCP send. And as we are approaching now the actual transmission of data, of a data string from system A to system B, I actually want to stop here. It's going to become very technical in case we would look into this method now. And I think it's not necessary for you to understand what's happening here. So unless you are like core MFS developer and want to do any changes here, which should usually not be required, it's not important for you to understand technical details of this step of the communication here. And it's important for you to understand that the MFS send function module is doing what it's doing, what I just explained in the last 20 minutes, and that at one point it's calling this class to induce the communication via TCP/IP with this method. And once this is done, data flows via your local or global network, and this data string, this telegram, which is at the end nothing else than a data string with zeros and ones, it flows towards the PLC, and it there stored into a receiving buffer. And the PLC, which received the telegram into its receiving buffer, will send an acknowledgement telegram back to EWM, and the processing of the acknowledgement telegram. And this may be the last step of MFS send. It checks whether we already received the acknowledgement. Once this acknowledgement is being processed, we remove the record for the telegram that we sent from EWM, we remove it from the outbound buffer table, the MFS delay. And this closes this communication round trip, and this also closes the telegram communication between EWM and the PLC part here. So forget about this additional details about the technical part of the communication here. And remember that we invoke the TCP/IP based communication, telegram is being received by the PLC, acknowledgement is sent back, and either directly or at one later point via the background job or via the processing of the next acknowledgement, it's being removed again from the buffer table. And that's it for the communication part. I would like to add a quick side note here about our period check background job, because I mentioned it a couple of times. And this job is responsible for many different things which need to be checked on a regular basis. It might trigger the repetition of telegrams based on the telegram protocol. So if I do not receive an acknowledgement yet, just repeat it, check whether we received any acknowledgements based on the acknowledgement telegrams that we received, process them and clear the outbound buffer, restart channels in this context. This report is automatically being started, or the background job is automatically being scheduled when you start a channel. Don't want to go into detail here, just that you understand this background job is running and covering some of the regular tasks which are needed in order to enable the way of communication that I just described before. Might add an additional video sometime in the future where we look into the tasks of this period job in a period check job in detail. For now, and for this video, that should be everything that I wanted to communicate. As a quick summary, we talked about the induction, so when is a warehouse task actually relevant to be processed by the subsystem? Remember the KZ flag in the warehouse task table structure. We talked about the preparation, so the decision which task of a given queue should be processed next. The creation, the collection of data to fill the telegram structure, reading the different MFS object, reading the data from the resources, reading the data from the telegram type, communication channel, PLC, and so on. Then the sending mechanism, Handshake protocol, and also the buffer table where we store telegram data or where we read telegram data in case we see there is something else which needs to be processed before our current task can be processed. And overall this protocol which is digging into every single part. Having said that, we looked at a specific example here with the creation of a telegram against a task which is just being created. And there are different scenarios where we import a telegram structure directly to the send function module, for instance, which was already stored in the buffer table, where we look at some different parts of the coding that I didn't touch here, but the general approach is similar, and the different checks and functions and logic is also similar. So I think with this video you have a good base to understand the communication between EWM and the PLC. You have some objects that you can use if you want to start debugging or looking into further details, and I just hope that it's somehow useful for you. If not, I'm happy to get recommendations or suggestions about what to do else, what to do better, what to do different. Having said that, 3 points to close this video. First one, thanks a lot to Swisslog and the EWM team at Swisslog again. Again, provided valuable input here, technical details for the full video series, and especially for that one. Feel free to visit their website to get in touch with them for your MFS projects. Second one, there's a blog series written by Jörg Michaelis and Tobias Adler, which is, among some other topics, also handling the receiving part from EWM perspective, so telegram from PLC to EWM, how this is being processed. I will put the link in the video description. I decided not to make another video about this topic because I have nothing to add to what they wrote here. And the third point, I would be very happy to win you as a subscriber for the channel. That motivates me, and that also gives you the benefit that you will be notified for new videos, and I promise you there is more to come within the next months. So thanks for today, goodbye, and see you next time.